Welcome to UGC Net and GATE Computer Science students. In today's topic, I will be discussing what are the expected problematic question for June 2020. So, actually, I am taking problems asked in subject is called System Software and Operating System. I taken from June 2012 to December 2019 as per June 2019 revised syllabus. You can reach me for any queries in this email. Okay, now I will go for what are the so far asked question from this system software and operating system, and these are the highlighted problems. As per my knowledge, okay, they'll be asking surely question from job scheduling, access time calculation, total effective time, bankers algorithm for job resource without deadlock avoidance algorithm, and disk scheduling algorithm, and very importantly page fault algorithm. Not only this, they will be asking some more question also. Okay, I straight away go for what are the question they were asked, how to solve it. Okay, so before going for this, and if you are coming to this operating system and system software, once again you will be studying in theory of computation concept. Okay, so now in this system software you will be discussing machines, what is assembly language, high level language, and then compiler and interpreter, loader, linker kind of things. And once we are coming for this operating system, we will be discussing many questions problematically from process management, critical section kind of things, then CPU scheduling, deadlock avoidance algorithm, memory management, storage management, everything here. Okay, so now what was asked in last few semester in December 2019, very interestingly they were asked given CPU time slice of 2 millisecond and following list of process. There are 3 process P1, P2, P3, and P1 entering with to complete the P1 we are having burst time 3 second, for P2 4 second, P3 5 second. Now when those process arrive to doing this job is P1 at 0, P2 as second, and P3 at 5th second. Find average turnover time and average waiting time using round robin CPU scheduling algorithm. So what is the specialty of this round robin CPU scheduling algorithm is, okay, whatever process coming and they has to do its work in the with the resources, it has to be done within some stipulated time, okay, limited time. If suppose a process coming and it has to complete within 3 minutes, suppose we have set slice as 2 millisecond, then both in millisecond, then what it will do is it will do such a P1 job only for 2 millisecond. If suppose it need 3 millisecond, after completing 2 millisecond it will be keeping such a process in queue, and next P2 come, it will perform for 2 minutes, then after that it will be keeping rest of the time limit with the queue. Okay, so like that it will do. Okay, that is the very interesting algorithm. Okay, so here what you have to do. Okay, so now how it will be completed, that will be represented with Gantt chart. Okay, so P1 arriving at 0, we are starting our process at 0. Now P1 will be complete for 2 seconds. So now again we want to keep that P1 in queue. Okay, now what happened, P2 coming, it will be completing for 2 more millisecond. So now what happened, you want to keep in again in queue. And now what happened here is here you want to note following information. This P1 coming at 0 second, it will be served first, P2 will be served second. Now again P1 will be going to queue, before this P3 coming, because P3 coming at 5th second only. Okay, now I mean from 0 to 4th, after that, okay, so P1 will be queued for second time. P1 will be coming first before P3. Okay, because this arrival time. Okay, so that's why P1 again served for how many, even slice time is 2 millisecond, it will be served only for 1 millisecond, because we need totally 3 milliseconds. So already P1 served for 2 millisecond, it will be another 1 millisecond, so the task will be over. At 5th second, P1 will be completing its task. Okay, now what happened, P2 will be served here. Okay, so now because after this 5th second, P2 already in queue. Okay, now P3 only entering inside queue. Who will get priorities? Only P2. That's why we are again already P2 served for 2 seconds. Total time required for P2 is 4 burst time. So now P2 will be completed. Okay, after that what happened, P3 will be only process every 2 millisecond, it will be completing its charge. Totally it need 5 millisecond, so 2 millisecond, 7 plus 2 9 equal to 9, 9 plus 2 equal to 11, second time, third time 11 plus 1 equal to 12, because 5, 2 plus 2 plus 2. Okay, so now it is Gantt chart. Okay, so now P1 and that. Okay, what is the burst time? Okay, so burst time, it is nothing but how many time it need to complete its task. Okay, when it is arrived, and what is the completion time. So from this concept we are representing. So now how to complete turnover time is nothing but what is that, completion time minus arrival time. Okay, 5 minus 0 is 5, 7 minus 2 equal to 5, 12 minus 5 equal to 7. Okay, how much time it waited. Okay, so P1 finished at 5th second. Okay, and initially it done, after that you wait for 2 seconds, that is your time here. And like that, how much time P2 waited. Okay, so P2 waiting, you want to calculate from here. Okay, in between this P2 P1 only complete for 1 second, so that is the waiting time for this P2. Okay, how much time waiting time for P3. So now when we are at here, P2 and P3 in race. Okay, so that time it has to, while P2 completing its chart, that time it waiting, so that is 2 seconds. Okay, so now what is average turnover time? So you want to add up all the turnover time divided by number of job. Okay, which means process. Yes. Okay, 5 plus 7 divided by total number of process. 3. So it is 5.66. Average waiting time is nothing but 5 divided by 3. Okay, 1.66. Hope you got very clear idea about this one. Okay, so next one is, suppose the system has 12 magnetic tape drives, and at time t0, 3 processes are allotted tape drive out of their need as given below. Okay, so now what happened, maximum needs and current need, P1 P2 P0 P1 P2. Okay, its maximum need is 10. Currently we allotted 5 resources for this P0. P1 need maximum 4, but we already allocated 2. Now P2 need 9, but already allocated 2. Okay, now totally we have 12 magnetic tapes, but we reserved 9 magnetic tape. In our hand we have only 12 minus 9, 3. Okay, so now in this case, if you are reserved maximum need and currently allocated, and some of the resources in our hand, with help of that we want to complete all the job. And for this, if record number of resources at any particular time for any particular process is available, then we can complete it, otherwise it leads to deadlock. Okay, so now they are asking at time t naught the system is in safe state. They are saying that it is in safe. Which of the following sequence so that deadlock is avoided? So they are saying that it is safe. We want to check out. Okay, so now maximum need this one, remaining allotted resource this one, remaining we need this one. Now what we do, we totally 12 resources, 9 resources already allotted. Okay, so only we are availability of such a resource is only 3. Okay, so now in order to complete p naught we need what 10 totally, but already 5 allocated, but 3 only we have, so we cannot do p naught now. Next I am checking for p1, so totally it need 4. Now we allocated already 2, our availability is 3, so I can give this 2 from this 3, so it is completed. Now p1 will be completed first. After that the in our hand we have 3 already, it allocated 2. So if after completing this p1 we want to deallocate such a resource to our critical section, so already it is 3. Now 2 will be released, so 2 plus 3 5. Now I want to complete for sequence, should not go back in reverse. So now what happened, I am coming to p2. So it need totally 9, but allocated only 2. In our hand we have what, initially we had 3, after completing it releasing 2, so totally 5 we have, we cannot do. So again I am going for second cycle. Okay, so in second iteration what happened, so we need totally 10, but it have already 5. In our hand also we have 5, so 5 plus 5 10 I can do. After that you want to release it. Now what happened, so p1 followed by p naught will be completed. So now after completing it will release its allocated resource. So previously we got 5, now it releasing 5 plus 5 10. Okay, now we need 9, it allocated already 2. In our hand we have 10, so I can give 7 resources for this remaining need. I can do it and I can complete. So now what is the order, it is in safer state, and order is p1 followed by p naught followed by p2. Okay, the answer option is p1 followed by p naught followed by p2. Okay, so this way we want to do it. Okay, so next question is, consider a paging system where translation look a side buffer TLB, a special type of associative memory, is used with hit ratio of 80%. Assume that memory reference take 80 nanosecond and reference time to TLB is 20 nanosecond. What will be effective memory access time given 80% hit ratio? Okay, so what is this concept? Usually we will be keeping our data in main memory as well as in secondary memory. Okay, whatever data present in main memory, its address will be keep in this TLB table. Okay, what are the data available where it is. Okay, so which means suppose you want to complete any task. For that 80% of needy data will be already available in main memory, that indicating that 80% is hit ratio. What is miss ratio? 100 minus 80 equal to 20. Okay, so now if you want to access data from directly from memory, it will be taking some time, plus suppose it is not present in main memory, you want to reload from secondary memory to main memory. For that how much time it will take? Okay, for the total effective time will be formulated as TLB access time plus miss ratio time, then into memory access time, and then memory access time for hit ratio, like that. Okay, miss ratio into TLB access time is 20 into hit ratio is 80. Okay, so then plus 80, that is for what, this memory reference take 80 second, so it is 20 plus 16 plus 80, 116 milliseconds. Okay, this way you want to calculate it. Okay, and next one is with respect to semaphore and wait and signal process. Counting semaphore is initialized to 8, 3 wait operation and 4 signal operation and are applied. Find the current value of semaphore value. Okay, it's very interesting. And what is wait and signal given? So for signal is nothing but r add it, or v is another signal here. Initially size is 80 and 3 wait operation, 4 signal operation. So the default formula is number of initialized sum 4 value minus how many number of wait plus signal. Okay, so 8 minus 3 plus 4, 5 plus 4 is nothing but 9. Okay, so I'll be stopping here. Okay, remaining questions I'll be discussing in next part of operating system and system software. Thank you for watching.